The last part of 1.3 talks about the difference quotient. And the difference quotient is actually a formula or a ratio that plays an important role in understanding average rate of change. Average rate of change you will hear in pre-cal and in calculus, and is also known as slope. So the average rate of change is just another way of obtaining slope. In calculus, that is the study of average rate of change on different types of functions. And the first part of calculus, you will study about limits. And the definition of a limit involves this difference quotient. And we'll revisit the difference quotient later on in chapter 11, and I think in the middle of pre-cal a little bit as well. All right, the difference quotient is going to look really confusing to you at first. You've got f of x plus h minus f of x, all divided by h, where, of course, h cannot be 0. I told you this is another name for slope, and the reason is, recall that f of x is another name for y. And h, in this case, represents your horizontal displacement. And if you'll remember, in the slope formula, you have y2 minus y1 over x2 minus x1 in the old slope formula that you know. And recall, x2 minus x1 is also another way of describing horizontal displacement. And then your f of x values is your vertical change or vertical displacement. So we have f of x plus h, some horizontal distance added to some x, and then you're going to subtract it from your original x. Your original y value that's associated with your original x. So some x value here, some y value corresponding to a horizontal distance added to x, minus your original x, or the y corresponding to your original x. Hopefully I didn't just confuse you even more. But you have to definitely take this formula piece by piece when you are asked to evaluate it for a certain function. So I'm going to start off with some easier type problems, and we're going to work our way up to the hardest ones that you will see. Okay, in number 1, you're asked to evaluate the difference quotient for the given function. The first one we're going to start off with is f of x is 6x plus 1. Your goal when working these problems you want your denominator to cancel as much as possible. So we want our denominator to cancel. And you're going to see, once you work them, you're going to see something kind of neat that happens, or you will appreciate it anyway. So the very first step Step 1, you take the x plus h, because essentially what you're doing is I'm plugging in x plus h into this function everywhere I see a variable for the first part. So take x plus h and plug in for all variables. Then step 2, the second part of it, so this goes along with step 2, this goes along with step 1. So the second part of this formula says that I take my original function, because that's what f of x is equal to. Notice that f of x is equal to 6x plus 1. So I'm going to take all of that and plug in after the minus sign. So be careful with that minus sign. So step 2, plug in the equation that you're given, or rather the expression. So we'll say the expression. 6x plus 1 after the minus sign. And you have to change the sign of everything. Change the sign of everything after the minus sign. Because in other words, you're having to distribute that minus sign. And you're going to see what that is in a minute. Okay, you don't plug in anything for h, rather, sorry. Don't plug in anything for h. All right, let's go through step 1. So we're going to take our formula, f of x plus h minus f of x all over h. All right, for step 1, I'm going to take my function, 6x plus 1, and we're going to plug in x plus h everywhere I see an x. So that's step 1. This is telling me I take that whole chunk and plug it in everywhere I see a variable. Then we've got this minus sign that is built into your formula, and I always put what comes next in parentheses. So then step 2 says I plug in the expression 6x plus 1. That was what f of x is equal to. So you take that chunk and plug it in after the minus sign. So it's your function with x plus h plugged in minus the original all over h. And you're going to see where h comes in a minute. It just kind of hangs out. Your h value should always cancel off. H value on the bottom should always cancel off. Now we have to go through and follow order of operations. Distribute, combine like terms. And remember when I told you that you have to change the sign of everything after the minus sign? Because it gets distributed, in a sense. Okay, so when we clean this up, distribute 6 to x and h, and bring down your plus 1. Distribute this minus sign to both of those, or in other words, just remember to change the sign of everything. So 6x now becomes negative or minus 6x. Positive 1 now becomes minus 1. And of course that's all over h. Now combine like terms. So we did distributive property here. And then we're going to combine like terms. So notice, and some things should cancel off. A lot of things should cancel off if you do this correctly. If you do a problem and a lot of stuff's not canceling out, H's do not cross off, then you always need to double check your work. So notice that my 6x cancel. Notice that my 1's cancel. And I'm left with 6h over h, which further simplifies to 6. So yes, all of that worked for 6. Now, when I go back and show you something really cool, I told you that difference quotient is another way of finding average rate of change or slope. If you will recall, this is in slope-intercept form, and where your slope is 6. I'll be done there in a minute. I'm almost done. But remember the y equals mx plus b? So this one is really easy to tell because this is a linear function. So yeah, I'm sure you're asking me, why do we do all that work when we can just look and get the slope? Well, I'm going to make you know the difference quotient and definitely make you show me how you got 6 using the difference quotient. But where it actually comes into play in a better sense is when we have quadratics, which you're about to see. And we can't just simply look, oh, okay, well, there's my average rate of change for any part of that graph. Next problem. Same directions, evaluate this function, or find and simplify the difference quotient for this function. And we are given f of x equals 2x squared. And write the formula every time. F of x plus h minus f of x all over h. Once again, step 1 is to take x plus h, plug it in everywhere you see a variable. So that was step 1. Step 2 is to write your original equation, which is 2x squared, or original expression rather, after the minus sign. And then we're going to distribute or change the sign. And just bring over the lovely h that's hanging out on the bottom. Okay, here's where it takes it up a step. Look at what you have here. You have to do exponents before you multiply the 2. Very common mistake. People want to distribute 2, then square. Please do not do that. So this is what we're going to look at first. So x plus h squared just simply means x plus h times x plus h, and you do the FOIL method. Multiply your first things together. So you get x squared. Multiply your outer, x times h. Gives you xh or hx, if you want to write it in that order. Inner, positive h times x, xh. Multiply your last things together. You get h squared. Okay, Then we have to go back and plug that in, 4x plus h squared. And you still have the 2 that's out front. So we have x squared, and let's go ahead and combine like terms. So plus 2xh plus h squared minus the 2x squared at the end, all over h. Oops, did not mean to write that again. We've already squared it, thank goodness. Thank goodness we don't have to square that. Next step, let's distribute 2 to all 3 terms. So we have 2x squared plus 4xh plus 2h. And then let's go ahead and bring down the minus 2x squared. And then all over h. Remember, I told you once you combine like terms, some things should cancel out, and h's should cancel also. So you've got your 2x squared that go away, and you're left with 4xh plus 2h all over h. You better get used to factoring because you have to do that a lot in pre-cal. So on the top, notice both terms have an h in common that you can factor out. Or if you can see that, hey, I've got an h in this term, an h in this term, they share that denominator, so cancel. Or you can simply factor it out like this. So factor out, you're left with 4x, you're left with 2 all over h, and then that cancels, so your final answer is 4x plus 2. That would be your average rate of change, 4x plus 2, for any point on that graph. Of course, that's a parabola, and in any, what you're going to see later on in pre-cal, tangent line, that would be the slope of that tangent line. So how you know when you're done, this is a common question I get. Plug in, do your math, distribute, combine like terms, cancel as much, factor and cancel as many things that will, and then you, like I said, typically you will not have an h in the denominator left. All right, we're about to do one of the hardest ones that you're going to see. So this is number 3. Find and simplify the difference quotient for the following function. Negative 2x squared plus 5x plus 7. All right, once again, here's your formula. So we take and plug the first part in, which says I'll take and plug x plus h in everywhere you see a variable. So we have negative 2 times x plus h squared plus 5 times x plus h plus 7. That is just your first part. And the only reason I'm using brackets there is just to indicate that. That's just your first part. Then you bring down the minus sign that's in the middle, and then we're going to do this last part. Step 2 says I take my original expression and plug it in after the minus sign. And remember, I told you when you're plugging in to use brackets or parentheses here to let you know this minus sign is going to change the sign of everything after it, what you're going to see. So I'm going to plug in my original here. And then, of course, that is all over the lovely H. That's on the bottom. Now, next step is to go through and simplify as much as possible. No, we have to do this part first, do your exponents first before you multiply. We've already figured out what x plus h squared was up at the top, but I can show you out to the side again if you need me to. So x plus h times x plus h, do the FOIL method, and you get x squared plus 2xh plus h squared. And that's what we have to plug in here. So let's keep going. We got negative 2 times x squared plus 2xh plus h squared. And let's distribute positive 5. So we have plus 5x plus 5h. Bring down plus 7. And let's change the sign. So you got to make sure you distribute that negative sign to everything over here. So this is going to become plus 2x squared minus 5x minus 7. And that was all over h. All right, we're getting closer. It's a lot of distributing, simplifying, but first, still have negative 2 to distribute to all 3 terms here. Negative 2x squared. Negative 4xh. Negative 2h squared. You can actually go ahead and simplify anything that you see over here that will cancel. Like for example, I see that my 5x, they will cancel off. I see that my 7s will also cancel off. But I'm left with plus 5h plus 2x squared, and then this is all over h. Combine like terms. Notice your 2x squareds will cancel off, and then we're left with negative 4xh minus 2h squared plus 5h all over h. You need to factor out the h that all 3 terms have on top. So let's factor that out. And then we're going to be left with negative 4x. When I factor out an h from this term, minus 2h. Factor out h here, I'm just left with 5. That's all over h. Finally, last but not least, your h cancels off, which I told you hopefully it should cancel off in the denominator. You can be left with an h in the numerator. We just want the one on the bottom to cancel. So finally, my answer is negative 4x minus 2h plus 5. I've combined all like terms. My h canceled on the bottom, so I'm on the right track. Actually, we're done. Okay, and that is a lesson on how to do the difference quotient.